This is a series of videos to see how ready you are for the acid-base test and the water properties test. There are questions, and you should pause the video and try to explain the answers, and then restart the video and see if your answers match what I say. So after each question, I won't say pause this time, just pause the video after I ask you this question. So question 1, what is the shape of the water molecule and why is it polar? Now this is something we did cover in earlier the year. So let's see if your answer matches mine. Pause video. I'll say that only once. Okay, so here's the answer. So oxygen is here, and then we got a bond to a hydrogen like this, and another bond to a hydrogen like this, and we call that a bent-shaped molecule. All right, now why is it polar? Well, oxygen is very electronegative and pulls electron towards itself and makes a negative charge on it. It's not really a formal +1 or -1. In this case, it's just going to be something that is a partial charge. And then that makes the hydrogens slightly positive. And we say that it's polar because it's got two charges, a negative, okay, and a positive charge. So there's your answer. Let's go on to question 2. How do water molecules bond to each other? Well, they do it by hydrogen bonds. So what exactly is a hydrogen bond? Let me draw 2 water molecules here. Here's a water molecule like this. And remember, we have the slight negative here and slight positives here. They bond because, let me draw another water molecule here. The negative of the oxygen is attracted to the positive of the hydrogen, and that's what's called a hydrogen bond. So they are bonded to each other by hydrogen bonds. When a hydrogen atom from one element is bonded to an oxygen of the other element, nitrogen and fluorine are also included on that, by the way. It is called a hydrogen bond. Okay, next question. Properties of water matching. This time I will say pause the video, see if you can match all these, and then I'll reveal the answers. So now assuming that you have paused the video, okay, water molecules stick to each other. That's going to be cohesion. We'll put letter C for that one. Water molecules travel up small tubes. That is capillary action, A. Water sticks to other surfaces. That's adhesion. So notice the difference between cohesion and adhesion. Cohesion is water molecules sticking to each other, and adhesion is when they stick to another surface. Surface tension D. Water has the ability to hold up a spider. We'll put that one right there. Okay, so all of these are related to each other, adhesion and cohesion. They cause surface tension, letter D right here. So a water spider can be on top of water, and water kind of makes a surface tension across because the molecules are all stuck to each other. Okay, next one. Water expands when it freezes. That's known as the density anomaly. Most substances do not expand when they freeze. They get more dense, but water becomes less dense when it freezes. The amount of heat to increase the temperature of a substance is called the specific heat, E. And normally that's per 1 gram of material. So specific heat is the amount of heat it takes to raise 1 gram of a material 1 degree Celsius. All right, there's our matching. Let's go on to question 4. Why is water called a super solvent? Because it likes to dissolve lots of things. But what does that mean? Let's take a look. What about something like sugar? We'll do glucose, C6H12O6. And we did this a long time ago. It's a solid. When it dissolves in the water, it becomes aqueous. So C6H12O6 and aqueous. So they like to dissolve polar molecules. Glucose is definitely a polar molecule. Water also dissolves something like salt, NaCl, solid. Under the presence of water, becomes Na positive aqueous plus Cl minus aqueous. One more time showing how it makes the aqueous ions. So these are all polar molecules and ionic compounds. So that's why water is a super solvent. dissolves lots and lots and lots of molecules. Okay, go on to question 5. Does water have a high specific heat or low specific heat? How does this affect its ability to change temperature? Let's take a look at the answer. Water has a high specific heat. I'll underline that right there. How does this affect its ability to change temperature? Well, it takes more heat to change temperature because of this. So it takes more heat. Let's talk about that briefly. So what that means, if I have a sample of water and I'm trying to warm it, it's going to take more heat to warm it. You might have heard the saying, a watched pot never boils, and that's where that saying comes from. But it's also true for cooling. It takes longer for water to cool. So it just takes longer for water to change its temperature because it has a higher specific heat. Remember, specific heat is the amount of energy it takes to raise 1 gram of the material 1 degree Celsius. There you go. Now, again, if you're talking about cooling, that means the amount of heat released when 1 gram of a substance cools by 1 degree Celsius. You can think of it either way. Let's go on to the next question. Does evaporation of water release heat or absorb heat? And why is this important to us on a hot day? Answer. It absorbs heat. Let me underline that one then. So in order to evaporate something, you must put energy into it to make it go from a liquid into a gas. This is called its heat of vaporization. You have to overcome those hydrogen bonds in order to allow water to escape from the surface. This is important to us on a hot day because if we're all sweaty, we got water on us and probably some salt and other grease and grime, but when it evaporates, it takes energy away from our skin and that cools us. So that's why when wind blows on us, when we're wet, we feel colder because it absorbs energy from our skin in order to evaporate the liquid. All right, let's try a couple more questions in this video. Does freezing of water absorb heat or release heat? Answer. When you freeze water, it's the opposite. It releases heat. Just think of it this way. In order to freeze something, you've got to get rid of energy, slow down those molecules in order to make a crystal structure. They're going to be moving less than if they were in a liquid. So you got to make them go slower in order to make a nice crystal. Therefore, you've got to get rid of heat. That's it for video number 1. Look for video number 2 coming soon.